the introduction, the simultaneous presence of several heavy metals is very common in contaminated soil. The competitive effect between heavy metals influence their retention and transport behavior in soil environment. The earlier study about competitive sorption studied from 4 major kaolin. The sorption of 4 major kaolin involved only non-specific sorption. This kind of sorption happened very quickly and also sorbed at relative lower affinity site. But for trace metal sorption, they involved both non-specific and specific sorption. As we know, specific sorption takes time and it absorbs at relative high affinity site of soil surface. As we all know, kinetic behavior is well known for trace metal because of several reasons. Here we just use the animation to introduce the non-specific and specific sorption difference. Non-specific sorption were sorbed at soil surface with a relative low affinity site. The bonding strength is relatively low and surrounded by water molecule. The specific sorption bond with soil at higher affinity site and the bonding strength is relatively high, and this sorption takes time, even like days or months or years. So, because the sorption difference between the non-specific sorption and the specific sorption, the mechanisms of non-specific and specific sorption are different. So the extent of competition between heavy metal involved both sorption may differ. It is necessary to separately evaluate the effect of competition on non-specific sorption and specific sorption. How we can do this? In 2002, some scientists have started investigate the copper and zinc sorption by separate the non-specific sorption and specific sorption in the presence and absence of competition. They think those sorption can be exchanged by the high concentration of calcium, referred to the non-specific sorption, and those cannot be exchanged by calcium was referred to specific sorption. Use this experiment method, they conducted the competition experiment between copper and zinc in the presence and the absence of competition. So they found it. The non-specific sorption of both arrows reduced in the presence of competition. Thus we commonly observed. This result was commonly observed because, as we all know, there is a competition happen and then some part of sorption was decreased. That we refer here as a non-specific sorption. But the amount of zinc sorbed at specific site, here referred to still retained on the soil surface after calcium exchange was increased. So the amount of zinc sorbed at a specific site was increased. As a result of sum of non-specific sorption and specific sorption, the total amount of sorbed zinc were reduced in the presence of counter ion, which here is copper. Another scientist in Spanish, they use Langmuir equation to evaluate the competition. They refer the bonding strength parameter K, they think if K is higher, then that means the bonding strength between the metal and the soil is higher. If the K decrease, then the bonding strength between the heavy metal and soil decrease. So their experiment was conducted, and they found that K tends to be higher in the presence of competition, which indicate that metal are held more strongly in the presence of competition, although the amount sorbed on soil was less. That means the total absorbed amount was less or was decreased. Here we have a new concept about competition. On the soil surface, we assume heavy metal was absorbed on two sides. First is non-specific site, and another part is specific site. Then, when other competition iron or counter iron go into this system, we will observe some original sorbed on the soil iron was exchanged out through this system, but part of a metal was retained on the lower affinity site, was pushed to sorbed at higher affinity site because of the competition at lower affinity site. So here we have two parts because of the competition. Some part was exchanged out to this system. Some part was pushed to higher, sorbed at higher affinity sites. That's the new concept. That's how the Spanish scientists proposed that competition for common sorption sites, here we refer to as a lower affinity site, between heavy metals would force heavy metal sorption on more specific sites or sites with higher affinity. Those previous works focused on equilibrium condition, but less work was done under dynamic flow. Let's introduce our study. We used two soils, Winter and Olivier. We used a column experiment to conduct the experiment. A solution was pumped into the soil column, and then the effluent was collected by those fraction collector. Next is our experiment design. For each soil, we have three arrangements. The first column, we input only single nickel. Only nickel was applied into the soil column. The second column design was first we input nickel and another pulse of cadmium input. We stop a little bit.